Hello friends, this is Partho sir. Today I am going to discuss one of the important areas of motional EMF. That is basically we have dealt with the electromagnetic induction chapters. Now we have seen from the IIT Advanced JEE Main as well as other exams, engineering exam, competitive engineering exams question paper that there are some problems which are not only coming directly from only one chapters. So few of the concepts related to the simple harmonic motions, hydrostatics, work per energy, as well as motion in a plane are also interlinked once we are dealing this electromagnetic induction or motional EMF. Now today I am going to discuss one of the important problems that has almost similar kind of type where the multiple type of concept from different chapters are required once you will try to solve this kind of problem. Eh, let's see how it can be solved. Here it is mentioned that a conducting rod length is L which is hinged at a particular point O. That means this is the length of the conducting rod, that is OP, which is hinged at a particular point, that is O. And it is free to rotate in a vertical plane. That means the rod is this and this can rotate like this. This is the vertical rotation of the rod. So if it is hinged over the point O, it can rotate like this. Okay. Now there exists a uniform magnetic field. Suppose this uniform magnetic field is B, which is acting vertically downwards along the plane. So a rod is released from the position and as shown in the figure, and what is the potential difference between the two ends. That means we have to find out what is the potential difference, because this is one point potential difference of energy. So what is the potential difference of the energy, I think. So this will be the questions that you have to find out. So once you'll see the potential difference across the induced EMF. So this is be between the point O and between the point O and N. Now first what we'll do, we will use the conservation of energy principle. Now first we have to see that whenever the rod which is fixed at the point O and when it falls from the point P to N, that means the extreme end of the rod was P, when it has dislodged and reached to the point N, then what is the movement or displacement of its CG? Because the rod is weight, it is m. Now if the weight of the rod is m, so here it is seen that obviously this mg weight will act in the vertical direction, that is from the point R. So from this particular area we have seen, if this we consider as x, so Rn will be also x. So Rm we can consider this is x. So OR, this length will be L by 2. So we can write down that is x by L by 2 is equal to sine of theta as for the trigonometry. So x is equal to L by 2 sine theta. This will be our simple first equation. Now let's consider as for the free body diagram, what is the loss of potential energy. We will find that the loss of potential energy is, that is m into g into x. So this will be m into g into L by 2 into sine theta. So this will be equation number 1. So we will get our first equation, that is loss of potential energy of the rod when it is dislodged from the point P and reached to the point N. Then what will be the potential loss of potential energy of the rod, and that we will calculate on the basis of the displacement of its CG. I mean how much displacement of the CG of this particular rod has taken place. Next area we have to find out that what is the gain of kinetic energy. That means we know that gain of kinetic energy is equal to the loss of potential energy. Now first thing, once this that particular rod has dislodged, now just look into this area. The rod has fixed at one end, so if it is dislodged, definitely it will move like this because this side is fixed. Now, once it is moved like this, it is quite clear there is no translational energy. That means no translational kinetic energy is present. Only rotational kinetic energy is present within the rod. So we can write down the gain of kinetic energy means that translational kinetic energy plus rotational kinetic energy. Now in this case, translational kinetic energy which is exists in this particular rod will be zero, because there is absolutely no translational movement of the CG, because CG once it has reached maybe in this particular position. So rotational kinetic of the rod will be half into I into omega square, where omega is the angular velocity of the rod at the furthest end. That means either in the point P, in whatever it is. So we know from the moment of inertia the value of I for a rod when it is fixed at a particular point, that is m into L square by 3. So if we put this value over here, then we will get m into L square by 3 into omega square. So this will be equation number 2. So we can say that the gain of kinetic energy, that will be equal to this, that is half into m into L square by 3 into omega square. Now as we know that the loss of potential energy is equal to the gain of kinetic energy, so we can write down that equation 2 and equation 1 will be these two will be equal. Okay, so we can write down m into L square by 3 into omega square. This will be equal to m into g L by 2 sine theta. Now if we strike out m, and here we'll get omega square is equal to strike out 2 also, we will get strike out 1L, so we will get g 3g sine theta, that divided by L. So from here we will get the value of omega, that is will be root over of 3g sine theta by L. Now the question is, that is the omega. Now in this particular area, we have seen the magnetic field is moving along the perpendicular direction of the plane, and it is moving the vertically downward direction, because as far as the sign is concerned, if the rod is moving in the vertically downward direction, and this is mentioned that horizontal direction, that means magnetic field is moving in the vertical downward direction with the plane. So what we will do, we will just put this formula, that is B is equal to that particular formula, induced EMF E is equal to E is equal to half into that formula we will use, that is half into B into omega into L square. Now value of omega you already know, so ultimately we will put that value, that is B into L square into omega. So the value of omega will be, that is root over of 3g sine theta by L. So ultimately the final answer will be coming down to, because here L to the power half, here square, so ultimately this will be 3 by 2, and in this case it will be dg sine theta. So this will be the final answer. Thank you very much.